Okay, let's get into our discussion on angles and degrees in trigonometry. I hope that you were able to download this worksheet, and if not, you can just follow along and take notes from this. First and foremost, trigonometry, as you can see, is the branch of mathematics that deals with relationships between sides and angles of a triangle. So you would think, well, how in the world can we use triangles to help us figure out values in a circle or in circular problems? You'll see the results of that as we go further in this. So let's just review some of our basic terms from geometry first. So our objective today is basically to use degrees to measure angles and sketch angles in standard position and to define what we call coterminal angles. All right, again, back to our review from geometry. Some of our basic terms that we need to remember first and foremost is what we call a line. And remember how that you can use shorthand to denote a line with the symbols, capital letters for points, of course, AB. So you would call this line AB. Okay, so either way you want to define that, that's fine. The second image that you see, of course, is called a segment, which is basically a piece of a line. Okay, a segment is a piece of a line, or it's like you've been cut. Notice that the arrows don't go on forever, but there's still 2 points, and so we're once again going to use our capital letters to denote the 2 points that are in our line segment, and there is our line segment. And then the next one, of course, is a ray. Okay, and a ray is very important because it has to start at a point and then go through another point. And so it's important that you denote that when you're writing that in your notes. For example, this starts at point A and goes through point B. So I want to make sure my A point is first, and then my B point, and then I'm going to draw my arrow above the top of it. If this would have been ray BA, for example, okay, let's put that in there, ray BA, for example, then we would have had to write it BA with a symbol like that. Okay, going back again to geometry, an angle in geometry was a figure formed by 2 rays that have the same endpoint. In trigonometry, every angle is formed by rotating a ray around its endpoint. Okay, in trigonometry, you can have negative angles. Remember, in geometry, most of your angles were between 0 and 180 degrees. It was true when you got into polygons that you got into angles greater than 180 degrees, but the majority of your work was in angles between 0 and 180 degrees. In trigonometry, you can have literally infinitely many degrees. For example, you could have 1,000 degrees, 10,000 degrees. You could have negative 400 degrees. The idea is that our endpoints, our angles, are going to rotate or spin around. I don't know if you've ever played the game Twister before, but imagine the spinner that you use to denote, you know, what color you're supposed to be on. That's exactly what you're thinking about here. Now, what we need to understand is that every angle has what's called an initial side, and then we're going to have what's called a terminal side. Initial just means where you start, terminal just means where you end. And so this angle, for example, would be opening in this way right here, which we call a counterclockwise way. And we would call this eventually we're going to call this a positive angle. Okay? However, if we have an initial side and we have a terminal side, and our angle now is opening in what we call a clockwise fashion. Now again, then we're going to call this a negative angle. Now, what do we mean by clockwise? If you ever looked at an old-fashioned clock that has the hands, there's 2 ways that you can go around that clock. Okay, so here's 12 o'clock, and here's 6, and here's 3, and here's 9. And so if you think about it, the hands of a clock, there's 2 ways. You can go around it in a counterclockwise fashion, which is like going backwards in time. But we're going to abbreviate that CCW. And then we can go in a clockwise fashion. So there's two ways that your angles can open, counterclockwise or clockwise, and that's going to become important in just a few minutes. Now, a degree we learned when we talked about radian measurement is 1/360 of a complete revolution. So there's 360 degrees, for example, in a complete revolution, and a revolution is one time around the circle. Okay? In geometry, as I mentioned before, angles were measured between 0 and 180 degrees. Now, we started classifying those angles in geometry, and this is just to review. An angle that's between 0 and 90 degrees is called an acute angle. An angle between 90 and 180 degrees is called an obtuse angle. An angle that is exactly 180 degrees is called a straight angle. That's one of the reasons why when teachers ask you what type of line do you have, most students will say straight. All lines are straight, but the reason why the word straight is used is because of the angle that usually is associated with that. We also want to talk about some Greek alphabet letters that we'll be using. And again, remember, trigonometry is one of the oldest math subjects. It's one of the very first math subjects that was studied at the university level. And so the Greek alphabet letters were used when you were looking for unknowns or to denote angles. And in this case, I just want to introduce them to you. It looks like a 0 with a slash through it. That's called theta. And then this symbol that you see a lot with breast cancer symbols, this is called alpha. And my last one down here that looks like a fancy B is called beta. Okay. Continuing on our review of geometry, we're going to discuss something called a complementary angle. Now remember, complementary angles are two angles whose sum is 90 degrees. So therefore, again, two angles whose sum is 90 degrees. So therefore, we're saying x plus y equals 90. I'm sorry if I said 180 earlier, I apologize, it's 90 degrees. Supplementary angles, on the other hand, are two angles whose sum is 180 degrees. So we go x plus y equals 180 degrees. Okay? Now there's a difference here. If I say the word complement, and not complementary, please pay attention to the difference. Complementary, two angles are added together equaling 90 degrees. But if it's just a complement, we're going to say it's 90 minus x. So for example, if I asked you what is the complement of 30 degrees, you would take 90 minus 30 and end up with 60. So the complement of 30 degrees is 90 degrees. We're going to get into that in more detail in just a few minutes. Supplementary angles are two angles whose sum is 180, but a supplement is 180 minus whatever your angle is. So if I asked you for the supplement of 100 degrees, that would be 80. Okay? Now, of course, from geometry, you had some basic problems that you had to solve. These are complementary angles, because notice this symbol right here means that this is in fact a 90-degree angle, so it's a right angle. We know a right angle is equal to 90 degrees. So to solve this, we're simply going to add these two angles together using our angle addition postulate from geometry. And we're going to end up with 9x equals 90, so x is equal to 10 degrees. Now x is just your variable, of course, but the values would be 30 degrees and 60 degrees, and 30 and 60 degrees are complementary angles. In our second problem, of course, since our angle here looks like a line, that's a straight angle, we know that's equal to 180 degrees. So we're once again going to use our angle postulates and add together our two expressions for our angles, and then solve. You're going to end up with 4k minus 4 is equal to 180. So 4k is equal to 184. And when I divide by 4, k is going to equal 46 degrees. Now again, k plus 3k is 4k, negative 6 plus 2 is negative 4, minus 4, and then we set that equal to 180 because these two angles are in fact supplementary. So if we put the 46 back in for k, we'd end up with an angle of 40 degrees here and an angle of 140 degrees here. Again, this is just a review of some of the basic concepts that you should already know. Now let's get into what we need to learn. An angle is in standard position, this is very important, if the initial side is on the positive x-axis. Very, very important that you jot that down in your notes. If you get nothing out of this whole worksheet, because the review you should already know, you need to know that an angle is in standard position in trigonometry if the initial side is on the positive x-axis. So we are always going to start our angles on the positive x-axis. Okay? And it doesn't matter where that angle ends up. For example, if I'm all the way over here in quadrant 3, that would be a positive angle drawn in standard position. You start anywhere else with your initial side. For example, I know in some other applications they may start on the positive y-axis. Okay? And then what they want to do is, you know, have an angle that terminates over here again. This is not a standard position for an angle in trigonometry. Okay, again, you want to start on the positive x-axis. So let's continue our discussion then about our angles now that we're moving forward. Angles are classified according to the quadrant in which the terminal side lies. If the terminal side lies along a coordinate axis, it's called a quadrantal angle. Now I know you say, what in the world does that mean? Well, if you remember back from your Algebra 1 days, your XY axis was broken into 4 quadrants. You have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I need to make this observation to you. Notice that your numbers, and you can go back and remember this from Algebra 1, notice that your quadrant numbers rotate in a counterclockwise fashion. Why does it do that? Because you're dealing with positive angles. So even in algebra, even back in middle school, your teachers were trying to get you to understand that positive angles start and they rotate in a counterclockwise fashion. Okay? And that's why your quadrants are 1, 2, 3, and 4. Counterclockwise means that the hands are rotating opposite of clockwise. So now what we're going to do are sketch some angles. Okay? Sketch just means to draw, and then we want to classify. So I'm going to take a look first at this 80-degree angle right here. I'm going to start this in the positive x-axis, okay, because every angle has to start there. And then we know that 80 degrees is not greater than 90 degrees, and so therefore we're still in quadrant 1. And when you sketch this, do the best that you can, but again, we want our same point here for our end point for both rays that form the angle. Here's our initial side, here's our terminal side, okay? And what I need to see when you sketch these angles is this arrow, so I can tell that you are in fact showing me that this is a counterclockwise movement around the circle, which is a positive angle, which is 80 degrees is. Okay, so this is in quadrant 1, so that's what we would do and we'd be finished with this problem. All right, what about negative 80 degrees? Well, again, we're going to start on the positive x-axis. So every single one of these problems, you're going to start, your initial side will be on your positive x-axis. Negative 80 degrees, well, again, we're not going to be going this way this time. We're going to be now going in a clockwise fashion. And so if you want to think about it, here's 0, here's negative 90 degrees, here's negative 180 degrees, here's negative 270 degrees as you go around in a negative or clockwise fashion. So we're going to drop down here, okay, and that's going to be my drawing, and this is in quadrant 4. All right. Now again, you'll need to practice this. You need to have your initial side and your terminal side, okay, in order to get this done correctly. And you need to show me the arrow, which means the direction in which the angle is moving. Okay, you'll need to practice this. And I'm going to leave you this worksheet to continue working these problems. But what I thought we would do is a little bit more practice over here. Okay, so we're being asked once again to sketch some angles. I'm going to go very quickly through this. And let's remember now what our quadrants look like. Quadrant 1, of course, is between 0 and 90. Quadrant 2 is between 90 and 180. Quadrant 3 is between 180 and 270. And quadrant 4 is between 270 and 360, because one complete revolution is 360 degrees. So again, if I'm going to sketch 240 degrees, I know that this is a quadrant 3 angle, okay, because why? It's between 180 and 270. So I'm going to go ahead and draw my x and y axis. My positive x-axis is where we start. And I'm going to rotate around over here to my third quadrant. That's where my terminal side will be located. And so now I'm done. Again, I showed my arrow moving around in a counterclockwise fashion. Drawing 315 degrees. Again, this is between 270 and 360. So this is a quadrant 4 angle. That means my terminal side is going to end somewhere over here in quadrant 4. And again, the best way to think about this is remember the spinner from the Twister game. Imagine there's 4 colors, right? And so what we're going to do is, it looks like that you'd be tempted to draw it this way. However, we're starting here and coming all the way around to the 4th quadrant. And that would be a positive 315 degrees angle drawn in standard position. Let's take a look at 150 degrees very quickly. This is a quadrant 2 angle. We're going to start on the positive x-axis. And we know that our terminal side is going to be somewhere over here in quadrant 2. You don't have to be perfect with this, just so we know that you are in fact in quadrant 2 and you're getting an idea of where these angles' terminal sides are. Negative 150 degrees. Again, if I'm thinking about negative, I'm moving in this direction around. So this is going to be negative 90, negative 180, or in a clockwise direction, negative 270. So if I'm at negative 150 degrees, I'm actually in quadrant 3. Okay. And so I'm going to start on the positive x-axis, and my terminal side is going to be over here in quadrant 3. And notice that my arrow is drawn in a clockwise fashion. These last few problems are angles that are greater than 360 degrees. And so what we need to think about is, if they're greater than 360 degrees, what does that mean? Well, that obviously means that we're going to go completely around the circle once. So one revolution is 360 degrees. So we're going to go completely around the circle once. So here's my y-axis, here's my x-axis. We're going to start on the positive. And let me try a different color here so that this might help some of you see it better. We're going to start on the positive x-axis, and we're going to go completely around the circle once. Okay, now if I take 560 degrees and I've gone completely one revolution, which is 360 degrees, I end up with 200 degrees. So now the question is where is 200 degrees? Well, it's actually over here in the third quadrant. So my terminal side is going to come all the way around to the third quadrant. So when I'm drawing an angle greater than 360, I'm going to start on the positive x-axis, do one revolution, okay, and then go all the way around. Anyone that's into skateboarding or snowboarding or anything like that, you'll hear them say things like 720s and 540s and things like that. That's referring to, or 360s. That's referring to how many spins or turns they're doing when they're doing a particular jump or something like that. So for example, a 720 would be 2 complete turns or 2 complete revolutions. 750 degrees, again, it's a positive angle. This time, as you can see, not only am I going to go around the revolution, around the circle one time, so I'm going to subtract 360, but when I take 750 and subtract 360, I end up with 390 degrees, but 390 degrees is still greater than 360 degrees, so I'm going to go around the circle again. And when I do that, I end up with 30 degrees. Now I know, see, what I want is an angle that is between 0 and 360. That helps me know which quadrant I'm in. If it's greater than 360, then I need to figure out which quadrant that I'm going to end up in. And so this is important that you end up learning these numbers, 360, 720, and then of course 3 revolutions would be what? 1080. Like I said, if you're a skateboarder or a snowboarder or something like that, you've probably heard these. 360, of course, and 4 revolutions would be a 1440. All right, that's 4 times around. That's really getting up there. But this is 2 times around, as you can see, and then 30 degrees more. So we're going to start on the positive x-axis. We're going to go around once. We're going to go around again. Now notice how I'm spiraling out from the center. Okay, I'm trying to keep this as neat as I can. And then I'm going to go 30 more degrees, which means I'm going to be in quadrant 1. So this is actually a quadrant 1 angle. Negative 80 degrees we've already talked about. It's going again in a clockwise fashion. Okay, it's in a clockwise fashion. And so we're going to start on the positive x-axis again, but this time we're going to rotate down. Okay, and there's my negative 80 degrees. Notice again, I still started. Every single one of my angles has started on the positive x-axis. Every single one. Last problem over here for practice is negative 630 degrees. Okay. Again, we're going to start on the positive x-axis, but as you can see, 630 degrees is greater than 360. So I'm going to take that negative angle, and this time I'm just going to add 360 to it. And I end up with negative 270 degrees. Now this is very interesting because 270 degrees is not in a quadrant. Okay? If the terminal side is not in a quadrant, we call this a quadrantal angle. It just simply means that it ends on a axis. It ends on the y-axis or the x-axis. So let's see if we can draw this. We're going to go in a clockwise fashion. We're going to go one time around. Again, I've got to make sure I'm showing the correct direction that I'm going, clockwise. But then I'm going to come all the way around again, all the way over here to the positive y-axis. Now again, why am I doing that? Because here's negative 270 degrees. I hope this helps you, and I hope you practice drawing your angles for trigonometry.